The first grade standard 1084 requires students to understand subtraction as an unknown add-in problem. For example, subtract 10 minus 8 by finding the number that makes 10 when added to 8. At its core, this standard is all about understanding the relationship between subtraction and addition. Too often, students think of these two operations separately and in isolation, and believe it or not, the most common reason is because teachers often treat addition and subtraction as separate and unrelated. For example, let's take a look at this word problem. There are 9 marbles. 5 marbles are red. The rest are blue. How many marbles are blue? When teachers say this is a subtraction problem, they convey to children that it can only be solved with a single operation, but that is clearly not the case. In fact, it's arguably more meaningful to represent this problem as 5 plus something is the same as 9, based on this story context. So, as teachers, we must constantly model the flexible use of both operations to solve problems that seem like they are purely subtraction problems. When 6 and 7-year-olds struggle to solve missing add-in equations, like 3 plus blank equals 7, pay attention to their thinking. If the child says 10, it's likely because they do not understand the meaning of the equal sign in this equation. As a teacher, you will want to check out the video on 1087 to address such misconceptions. However, it might be that the equation itself is too abstract for the child to comprehend, and therefore a story context and/or manipulatives will serve as a critical sense-making strategy. Remember the concrete, pictorial, abstract sequence. Use a simple story problem, or snap cubes, or pennies to model this equation. For example, I have 7 pennies in my hands. I have 3 in my left hand. How many are in my right hand? Then be sure to discuss how addition and subtraction can be used to represent the solution. It is absolutely critical that we give students plenty of rich opportunities to solve a variety of word problem types, especially with unknowns in the change and start positions. In other words, the types of story context where the result, total, or difference is known. The problems in these 2 columns are perfect for supporting student proficiency with 1084. This particular table can be found in the Mathematics Glossary on the GeorgiaStandards.Org K-5 Mathematics homepage. For solving missing add-in problems, students can use various counting strategies, including counting on and counting back. Initially, students might use their fingers to count, but help students to think of more effective counting strategies than counting all. Knowledge of fact families is also critical in helping students to see the connection between addition and subtraction. The use of number bonds and bar diagrams will help students to become fluent with these fact families. Be sure to use symbols for the unknown quantity, like squares, triangles, or blanks. This will help develop students' algebraic reasoning skills. And finally, remember to consistently use math tools to model solving problems. Students should be familiar and flexible with using 10 frames, recs, number lines, part-whole diagrams, and 100 charts to solve problems. A great digital tool for generating word problems for supporting subtraction as a missing add-in, use Greg Tain's word problem generator. You can also choose any of the word problem types, as I have selected a part-whole problem in this example. You can also control the location of the unknown value, and even control the size of the numbers. Finally, you can click Hit to see the problem represented with the bar model. From kindergarten, students should be familiar with number combinations to 10 and decomposing numbers less than or equal to 10 into pairs in more than one way. They also solved addition and subtraction word problems within 10, although only limited to result unknown word problems. Standard 1084 is a critical building block in developing early algebraic reasoning skills, particularly the flexible use of addition and subtraction as inverse operations. Caveman subtraction is a task from illustrative mathematics that helps students to understand subtraction as addition with a missing add-in. The key with this task, and any task for that matter, is that the teacher must help the students connect the abstract with the concrete and pictorial modes of representation. This is the essence of the second standard for mathematical practice. So what could this look like? In the following video, you will see that I present students with 13 snap cubes. I then cover 5, leaving 8 visible. The students have chosen specific tools to help represent the situation posed. However, modeling with manipulatives and pictorial representations is not enough. We must consistently ask students to represent quantitative relationships in the abstract mode. So here a child might write, 13 is the same as 8 plus triangle. Whether the student writes the correct equation or not, be sure to ask what each part of the equation represents. So for example, what does the 13 represent? That is the total number of cubes, or the whole. What does the 8 represent? That is the part that we can see. What does the triangle represent? That is the part that we cannot see, or the unknown. We must do this over and over to ensure that students are connecting the abstract with the concrete. Let's see what this could look like in a classroom. Notice that all of the students choose to first count the cubes that are visible before representing the total number of 13 cubes. This leads to an error for the student who is using the part whole mat, which I intentionally do not evaluate or correct. It was also intentional that students first modeled the situation in the concrete or pictorial mode before writing a matching abstract equation. As students are working, I am purposefully silent as I want them to engage in productive struggle and sense-making. I also encourage them to talk to each other about what they are doing and why. Listen to the interaction I have with Kennedy as she explains how she modeled the situation.
I put up 13 coins and then I flipped over 5. We have 13 red cubes. So I put 13 coins on my board, on my chart, and then I flipped over 5, and that's how I got 8.
Okay, great. So can you show me how you represented that with an actual number sentence? Remember to allow students to use tools such as 10 frames, part whole mats, etc. to represent the situations you provide. And then have students write several different equations that can represent the situations. First grade Georgia Curriculum Frameworks has several other rich tasks to support the understanding of subtraction as addition with an unknown add-in. They include lots of dots, what numbers can you make, fact families to 10, as well as story problems involving change unknown and initial unknown. In each of these tasks, students compose and decompose numbers, practice finding number combinations, and relate addition to subtraction.